We talked about how TCP connections are established with the SYN and ACK flags. And then we talked about the steady state and how sequence numbers and acknowledgement numbers manage that. But all good things come to an end, and so eventually we need to close our connection between the server and the client. Each end can be closed separately. So if a client, say, decides they have nothing more to say, they can close the send end of the socket. And then the server end, the other end of that connection, will receive a notification in the form of an end of file. So say the server discovers that the client has no more to say, then they can maybe send some last message to the client and then shut things down when they want. The connection between the server and the client will last as long as either end has the socket still open. But after they both close, then that socket can go away, the OS can reclaim the resources on both ends. So what does that look like on the package level? Let's suppose that host A is first to decide that it's done talking. So it sends a close message to host B, and that takes the form of the TCP packet that has the fin bit set. Remember, fin was one of those flags that's in the TCP header. So a packet with that bit set is a notification to host B that host A is done talking. So host B then can acknowledge that packet, and at this point host A knows that it will never send any more, and it knows that host B knows it will send any more, but it doesn't know whether host B is done. So when host B is also done, it too sends a closed message in the form of a packet with fin bit set. And at this point, host A knows that the socket communication is really complete. And so it acknowledges that packet, and now host B also notices that the communication is really complete, and it can reclaim its socket. But host B is actually in a better position here because it got all of the fin messages and sent the fin messages and got back the acknowledgement that its fin message was received. But host A actually doesn't know that host B received the acknowledgement to the fin packet. This is the usual sort of infinite regress of back and forth. So TCP addresses it by allowing host B here to really close the socket and reclaim its resources. But host A is going to wait a little while to make sure that it doesn't need to resend the acknowledgement to host B, to make sure it doesn't get another message from B saying, I sent you a fin, here's a fin, please acknowledge. So this timed wait state is something that you can see if you list all the connections that are open in your operating system. One of the implications is, suppose host A is the server, and you created the server socket listening at a particular port number, 22 say, and you know that host B has closed the connection because your host B is a machine sitting next to you and you can see that it's closed. But you still can't reuse port 22, you can't open a new listener on port 22 on your server machine because the OS is stuck in this timed wait state. And if you wait 30 seconds, then something that didn't work suddenly starts working again. You might wonder what the mysterious behavior is. It's that extra timed wait. Now, if you know about this, if you're doing sort of a test server, not a production server, then a common thing to do is to tell the OS through the OS level flag as SOU reuse address when you're creating the listener socket, and then you can tell it, really just give up early because it doesn't matter. In a production setting, though, it's better not to set this flag because the TCP protocol is set up to avoid extra collisions by doing this extra time wait, just in case. And it waits something like 30 seconds because that's about the longest that these extra packets that might be delivered to that connection could possibly be floating around the network.